So we're back with part 2, and just going to show you, I've already kind of got it going, and I just want to make sure I'm collecting the data right now. Nope. All right. It doesn't want to collect, so hold on. Okay, it's collecting now. I have 2 cans of pop here, okay? I have already poured this one right here was poured out about half of the contents. It's 355 milliliters in the can, and I don't want to touch these anymore. And so I've poured out about 175 there. So just estimated about half the can poured out. All right, so now we have half of a can versus a full can. They are both wrapped in a sock, the same type of sock, the best I could to get them to be the most similar. And so the only variable here is the amount of pop, okay, inside each of the cans. So the prediction is which one's going to gain energy faster or more energy by the end of the 30, we'll just say faster by the end of the 30 minutes. Is it going to be the half can of pop, or is it going to be the full can of pop? So again, they're both going to gain some energy because they've been taken out of the refrigerator. They're both in a sock, but the only difference is one of them has half the amount of pop in it. The other half is right there. Okay, and I'm just going to bring the other 2 cans of pop over so you can see that these are actually different cans of pop than part 1. So these are the cans of pop from part 1. So what we've got going here is 2 different cans. Again, one is half the amount of pop than the other. We can see the temperature starting to collect there. Now this time I have set it to be every 30 seconds for 30 minutes. Again, I'm not going to show this video the whole 30 minutes. I'll come back after 30 minutes and we'll look at the temperature. So predict. Which one do you think is going to gain energy, more energy or quicker energy by the end of the 30 minutes? Or do you think they'll be the same, that the amount of pop doesn't matter? So make a prediction. Talk about it in your groups. We'll be back. All right. So like I said earlier, I changed it so it was taking the temperature of each of the cans at every 30-second intervals. So we can see the graph a little bit more distinctly here. I know that there's a lighting issue, but there's one of the points and there's the other point. I'm going to try to see if I can fix that lighting issue. You can kind of see at the beginning versus the end here, okay? So they're near the same temperature at the beginning, and they are much different at the end, okay? So just to remind you, temperature, all we're doing when we get the measure, the temperature measure, is we're just measuring the kinetic energy of the molecules as an average. So we're just, temperature is just measuring average kinetic energy of the liquid, okay? Let's see, communication has occurred, that's okay. We got our results anyway. So just remember that. And so now you have a can that is half full versus a can that is completely full. One of them gained energy quicker, and I'll let your teacher talk to you about which one did that. But think about it. You've got a certain amount of molecules in one can versus a certain amount of molecules in another can. Is there a can that has more thermal energy just because it has a certain amount of molecules? In other words, the can with the most amount of pop has the most amount of thermal energy because each little molecule is carrying a certain amount of energy. So if you have more of those molecules with that energy, with each carrying some energy, then it makes sense that the can that is full has more kinetic energy just because it has more molecules carrying kinetic energy or more kinetic energy. Each molecule might be, at the beginning, each molecule was carrying the same amount of energy. okay? But one can, the one with more liquid in it, overall, the whole can had more thermal energy than the one that was half filled, just because it has more molecules, okay? So I'll let your teacher kind of talk to you about that. If you have more questions about that concept, then talk to your teacher about that. But one of them did gain energy faster, and maybe it's what you predicted. So, all right.